We will now move on to the last subtopic of 3.2, that is absolute values. The objective of the subtopic is to define modulus x less than a, modulus x greater than a, modulus x less than or equal to a, and modulus x greater than or equal to a, as well as to solve absolute values involving linear inequalities. Inequalities, I have four types of inequalities, and they are less than, greater than, less than or equal to, and also greater than or equal to. So now I will use definition for defining these four inequalities involving absolute values. So for the first one, I have modulus x less than a. I can write this as x to be between a and negative a. In this form, this means that the left-hand side and the right-hand side will happen at the same time. So I can write it as negative a less than x and x less than a. In mathematics, and means intersection. Now the second case, I have modulus x to be greater than a. By definition, I can write it as x greater than a or x less than negative a. In mathematics, or means union. Now case number 3, if I have modulus x to be less than or equal to a, by definition, this time I get x to be between a and also negative a. However, this time inclusive. Okay, because there is an equality. Breaking them into two parts, these two on the left and on the right will happen at the same time. So I have negative a less than or equal to x and x less than or equal to a. In mathematics, and means union. And the last absolute values involving linear inequalities, I have modulus x to be greater than or equal to a. By definition, I can write it as x greater than or equal to a or x less than or equal to negative a. In mathematics, or means union. It is a bit similar to case number 2. However, in case number 4, there is an equality sign over here. We will use these 4 definitions to answer examples on the coming slides. For this example, we will play with basic definition, and the basic definition that we will use will be in the form of modulus x greater than or equals to a. We can write it as x greater than or equals to a or x less than or equals to negative a. So now I can have 7u plus 5 to be greater than or equals to 9, or 7u plus 5 less than or equals to negative 9. 7u greater than or equals to 4, u is greater than or equals to 4 over 7, and here 7u is less than or equals to negative 14, u less than or equals to negative 2. Two answers in the form of linear inequalities, and I have to combine them using or. In mathematics, or means union. So now I have to draw my number line because it is linear inequalities. Smaller number on the left, so negative 2 will be on the left, followed by 4 over 7. Negative 2 here, the dot is shaded because it has equality in it. Move to the left because smaller. 4 over 7 shaded, the dot, and also move to the right. So now I can do for my interval notation. Union means take everything. So look at the lines I've drawn just now. At the most left, it is negative infinity. Moving to the right, it will stop at negative 2. Open bracket, close bracket. I have two answers. In between negative 2 to 4 over 7, there is nothing. But starting from 4 over 7, there is a line. So 4 over 7, it will continue moving to the right until it approaches positive infinity. So here, positive infinity. My bracket at 4 over 7 is closed. Positive infinity here is open. Whereas for my solution set, I will get curly bracket. My variable this time is u, so u double dot. Here, negative infinity to negative 2, numbers that are smaller than negative 2. So u less than or equals to negative 2. Over here, this is open. Over here, I have two answers. I have to combine them using union. Okay, back to my solution set. Union means or. And now at the right hand side, numbers that are larger than 4 over 7. So u greater than or equals to 4 over 7. Now for this example, by using basic definition, I have 4x plus 7 to be between x plus 13. And over here at the left-hand side, I have negative. This time I have more than one term, so I have to put a bracket. So this is bracket x plus 13. Okay, the basic definition. Modulus x less than or equals to a. Modulus x less than a can be written as x to be less than a, less than, here negative a. So now I'm going to, I copied this wrongly. This is less than. So now I'm going to solve them, break them into two parts. So I have negative x expanding this, negative x minus 13 less than 4x plus 7. In this form, it means that it will occur at the same time, so n. And here 4x plus 7 less than x plus 13. Here I can play with comparison, so 4x plus 7 is greater than negative x minus 13. Interested in x, so bring all my x to the left-hand side. So this 5x greater than negative 13 minus 7. So here 5x greater than negative 20, x is greater than negative 4. And over here, bring all my x to the left-hand side, so 3x is less than 6, x is less than 2. Linear inequality, I have to draw my number line. In maths, n means intersection, so now smaller number on the left, which is negative 4, followed by 2. So negative 4 will move to the right, open dot, and 2 is also open dot, move to the left. Union means we will take away their meet, so these two lines will meet here. So now my interval notation is equal to, from negative 4 to 2, brackets are open, open. So solution set, I have curly bracket, variable is x, so x double dot. Over here, this means that my value of x is between negative 4 to 2, so x in the middle. Open brackets means there is no equality, so less than, less than. Now our last example, if we use basic definition, it will be in the form of modulus x greater than a. I can write this as x greater than a or x less than negative a. So now use the basic definition, I get 4 minus 3x greater than x, or 4 minus 3x to be less than negative x. Interested in x only, so I get negative 3x minus x greater than 4. This is negative 4x greater than 4. Okay, for inequality, if I have negative in front of my variable, I will negate everything. So I get 4x at the left, at the right I get negative 4. My symbol will also be reversed. So here I have x less than negative 1. On the other hand, over here, I get negative 3x plus x less than negative 4. So this is negative 2x less than negative 4. Similarly, like just now, if I have a negative at my x, for inequality, I have to negate everything. I get 2x and 4 at the right-hand side. My symbol will also be reversed, so this is greater than. So x greater than 2. Linear inequalities, if I have to combine them using intersection or union, I have to use my number line. For in maths, or means union. So now numbers that are smaller will be on the left. Negative 1 is smaller, followed by 2. So negative 1, open dot, move to the left because it is smaller. And 2 will approach to the right because x is greater than 2. Union means I'll take everything. So from my number line, interval notation, look at my line. At the most left, the arrow will approach negative. So negative infinity to negative 1. Open, open. Between negative 1 to 2, there is nothing. Starting from 2, there is another line. So I have two answers here. So to combine these two answers, I will use union. Next one is 2. Arrow will continue to the right, so positive infinity. So open, open. In between, it is union. Now for solution set, I have my curly bracket, x double dot, negative infinity to negative 1 means that numbers that are smaller than negative 1, so x less than negative 1, union means or, and over here I have x greater than 2.